So welcome to another series of lecture. In these lectures, we will study engineering mathematics. So first, we will start with matrix and determinants. So matrix is a matrix. This is an example of a matrix. So in matrix, we are faced with four types of problems. First, there are types of matrices: symmetric matrix, skew-symmetric matrix, singular matrix, and other types of matrices. So, and then we have to find the questions regarding finding the determinants of matrix and also the inverse of a matrix. Then we have eigenvalues and eigenvectors of a matrix. And then we have the questions, problems regarding characteristic equations. So first we will study types of matrices, so symmetric and skew-symmetric. In a symmetric matrices, what happens is that this is a diagonal. This could be anything. Diagonal elements could be anything, but the upper triangular matrix and lower triangular matrix must be same. So that is symmetric matrix. In skew-symmetric matrix, if we have A, so if we take transpose of a symmetric matrix, so A transpose equals to A. Then in a skew-symmetric matrix, what happens is if we take transpose, B transpose is equals to minus of B. What actually happens is that this upper triangular matrix elements and lower triangular elements are opposites of each other. Actually, they are negative with negative sign. If there is plus one here, there will be minus one here, and this could be anything. This is zero. In skew-symmetric matrix, the diagonal elements are zero. So then we have a type of matrix called singular matrix. So singular matrix are those matrices whose determinant delta singular equals to 0. The determinant is represented by this symbol, the bar symbol or the triangle symbol. So determinant s equals to 0 or this s determinant the matrices whose determinants are equals to 0 is equal to 0 are called singular matrices. Singular matrices have no inverse because to find an inverse, what we actually do is divide the matrix. A matrix comes here, cofactor matrix or something comes here, and we divide that matrix by delta of the given matrix. So if this is 0, this is not defined. So in singular matrices have no inverse. So we can't find inverse because the delta is 0. Then we have we have problems to find eigenvalues and eigenvectors and the characteristic equation. We will take the first question here. Then we have invariance. Invariance. What are the invariants of a matrix? For example, if we take a two-dimensional matrix, so this is xy and xy. Okay, let's suppose we took a three by three matrix. So what we will get a characteristic equation of a 3 by 3 matrix will be a cubic equation, and a characteristic equation of a 2 by 2 matrix will be a quadratic equation. Similarly, for other polynomials. So invariance. So the characteristic equation will have an lambda cube minus a constant times lambda square, constant times lambda plus a constant. So these constants are actually invariants. So first, and also note that the minus sign is changing. First plus, then minus, then plus, then minus, then alternate symbols are there. So plus, minus, and this I1 is the first invariant, I2 is the second invariant, I3 is the third invariant. Similarly, for other degree of polynomials, there will be more invariants. So the first one is called trace. Trace is actually the sum of the diagonals. If we take the sum of the diagonals of a matrix, that is called trace. And then these are I2 is here actually this determinant plus this determinant plus that one, okay, that one, plus that one. So then I3 is the total determinant of the matrix. I3 is the total determinant of the matrix. So the middle ones are not so important. The first one and the last one. Last one is the determinant, and the first one is the trace. These two are important. So trace. So what we mean by invariant is here is that if we transform the matrix here through an angle width, if we suppose we have a Mohr circle and we have a stress tensor is in a form of 2 by 2 matrix, and we transform it along any angle transform it along an angle. So then the trace of the matrix and the determinant of the matrix will not change. Okay, invariance का मतलब है, and what we mean by invariant is that these values do not change if we transform the matrix. Okay, invariance. So we will take the first problem to find the determinant of the matrix, then inverse of the matrix. Okay, then we will go over trace. To find the determinant of the matrix, what we will do is we will use Sar's rule or something. So here we have 3 by 7, 2 by 7, 6 by 7. 1 by 7 is common in all of these, so we will ignore that. We will actually take that common and then solve the matrix. So 3 to 6, what we will do for determinant is 3, 2, 6, minus 6, 3, 2, 2, 6, minus 3. What we will do is again repeat 3 to 6, then we will again repeat this pattern. 3 minus 6, 3 minus 6, 2, okay, 3 minus 6, 2, then after this comes, then after this comes. So this is circular. Okay, so 2, 3, 6. Now what we will do is multiply these and add these, then multiply these and subtract these. Okay, that will give the matrix determinant of the matrix. So 3, 3, 3, 27 minus 27 minus 27, 2, 2, 2, that's 8 plus 8, and then 6, 6, 6, 36, 6, 6, 6, 36 into 6 minus 36 हो जाएगा 3 216. Then again 2, 3 and 6, we will actually subtract the upper arrows. So 36 minus 36, and then 3, 2 minus 36 minus 36, and then also 3 minus 2, so minus 36. And so what we will get is actually utilities calculator. Minus 27 plus 8 minus 2 16 minus 36 is minus 343 minus 343. Okay. then this is the determinant of the matrix. Then we have to find inverse. So what we will do for inverse is, actually we will then again this row and this row, we will, after this row we will write this row 3 2 6 3 2, and then minus 6 3 2 minus 6 3. So what we got is 8 1 2 3 5 by 5. So we will ignore the first and the second one, first row, horizontal first row and the first column, and then we will actually multiply, find the determinant of these, what I am circling, and then this determinant will be actually be the cofactor matrix. And what we will do is divide that cofactor matrix by that determinant, and then we will get the inverse. So what we get is, okay, 343 is the minus 343 is the determinant. Okay, so what is this? 3 into minus 3, minus 9 or minus 12. Minus 9 minus 12 is minus 9 or minus 12 is minus 21. Then 2 4 minus 18, 4 minus 6 is 18, 4 minus 18 minus 22, minus 20, okay, 4 okay, 4 minus 18, 4 minus 18 is minus 14. Okay, so we will not solve the entire problem here. This, what we are getting, we divide it by 343 actually. Okay, so what we get is see, 21 divided by 343 equals to is it 7 से divisible है क्या ये 7 से 3, 7 का 28, 7 5 35, 7 चौके 28, अच्छा 963 no 3 by 49, and this was 2 by 49. And actually what we did was we ignored the 1 by 7 here. So 1 by 7 was ignored initially. So what we will do is actually multiply it by 1 by 7 को हम अगर कॉमन ले लेते थे तो 1 by 7 इससे कॉमन हो गया, फिर 1 by 7 इसका क्यूब एक्चुअली कॉमन ले लिए थे हम लोग, तो इसका क्यूब से और डिवाइड, इसका जब मैट्रिक्स डिटरमिनेंट निकलता है तो ठीक है. So that's the Saras rule to find the inverse. What we do is actually write the same matrix 3 2 6 3 2 6, then again 3 and then 2. We write the initial matrix 3 2 6, then we this row was and this row that was okay. Then we put that okay. We found out the determinant and the inverse. Then the next problem is to find the eigenvalues and eigenvectors of a matrix. First we will take a simple problem regarding the trace was given. Okay. The problem is here 1 1 3 1 1 3 1 1 3 and 1 5 1 1 5 1 and 3 1 1. It's given that the minimum and the maximum eigenvalues are minus 2 and 6 respectively. Minus 2 and 6 respectively, and the third one is not known. So what we do is actually eigenvalues are the matrix which eigenvalues, okay, eigenvalues are -2, then this one, then 6, 0, 0, 0, 0, 0, 0, 0, 0, 0. This gets transformed to this type, this form, in which the diagonal elements are 0. Okay, and no, upper triangular and lower triangular elements are 0, and the diagonals are the only remaining elements here. So this is called principal matrix. Principal matrix. Only eigenvalues are there. So if the matrix get transformed, so the trace of the matrix doesn't change. Trace of the matrix doesn't change. So if the sum of the diagonal element is 5 to 7, this sum should also be 7. So -2 plus 6 is 4. So this should be 3. So 3 is the answer. 3 is unknown. So that was the problem regarding trace. Okay, the question is given 8 minus 4 to 2. 8 minus 4, then 2 is, we have to find the eigenvalues and eigenvectors of the matrix. So to find the eigenvalue, what we do is actually minus lambda here, and in the diagonal elements we subtract the diagonal elements by lambda, and then we find the determinant. So if we find the determinant, the secondary equation will evolve here. So that equation will be lambda square minus I1 lambda plus lambda plus I2. Okay, I2 equals to 0. Here I1 is a trace of the matrix. Okay, so trace of the matrix is 8 plus 2 is 10. 8 plus 2 is 10. So lambda square minus 10 lambda, and I2 is the determinant here. So 8 to 16 or minus 16 minus 18, 16 minus 8, 16 minus of minus 8, so minus 24 plus 24. Okay, 24 equals to 0. So iska solution, we have to find the solution of this equation. This will give the eigenvalues of the matrix. Okay, so actually we will do is we will factorize okay, what we can write is lambda square minus 6 lambda. We will bifurcate this into minus 6 and minus 4 lambda, then plus 24 equals to 0. Then lambda is equal to lambda minus 6, lambda common लेंगे तो, then minus 4 common लेंगे तो lambda minus 6 equals to 0. So lambda minus 4, lambda minus 6 equals to 0, which gives lambda equals to 4 and 6. These two are the eigenvalues of the matrix. We can see that 6 plus 4 is 10 here, and 8 plus 2 is 10 here. So that the trace of the matrix doesn't change if we transform the matrix. Then we have to find the eigenvalues, eigenvectors, eigenvalues. These 4 and 6 eigenvalues. Eigenvectors is actually what we do is 8. We will get the first eigenvector from the first eigenvalue, and the second from the second eigenvalue. So 8 minus 4 and then minus 4, 2, and then 2 minus 4. Actually we have to multiply this equals to get 0, 0. This is the eigenvector. What values should this and these should be such that if we multiply that vector by the matrix, we get 0, 0. So this is actually 8 minus 4 is 4, and 2 minus 4 is minus 2. Okay, so plus 4 minus 4, So plus 4 minus 4, if we put 1 here, so plus 4 and 1 here, minus 4, plus 4 and minus 4, that gives us 0. Okay, and then 2 and minus 2, so that also gives 0. So 4, the eigenvector corresponding to 4 is 1 1 1 1. Then what the second eigenvector is, we will put the second eigenvalue here. Second eigenvalue is 6, to 8 minus 6 is 2. This is minus 4. 2 minus 6 is minus 4. So if we multiply this by 2 and then 1, 2 and 1 here, okay. So 2 the 4 minus 4 equals to 0, 2 the 4 minus 4 equals to 0. So 2 1 2 1 is the second eigenvector here. So what is the physical significance of the, okay, so the system equation here is given is x, actually we will write it here, x plus 2y, x plus 2y minus 3z minus 3z equals to a, okay. Then 2x plus 3y, 2x plus 3y plus 3z equals to b, 5x plus 9y minus 6z equals to c, okay. So what we'll do is remove all x's and y's, but and write it that in a matrix form. So 1 2 minus 3 a, 2 3 2 3 3b 3b 5 5 9 minus 6 c. Or then what we'll do is actually really transform this matrix, okay. What we'll do is, so, okay, 1 2 minus 3 a, if we multiply, we have to the diagonal, we have to solve it such that the lower diagonal elements gets to 0. So then solving the equations will become easier. So okay, multiply this by 2. Actually what we'll do is, this is a, the second row will be b minus 2a, so 2 0, and that will be, let's solve it here, 0 minus 1 9b minus 2a. Then multiply this by 5 and subtract this, so 5 minus 5 c minus 5a, this becomes 0, this means minus 1, this 9. So what we see, that what we get here is that the second row and the third row are similar. That means these two lines are parallel to each other. So if we subtract this by this, what we get, we have to, the question says that the system will be consistent if ABC satisfies the equation. For this to be consistent, this actually c minus 5a, you subtract these two last rows, minus b minus 2a, actually plus हो जाएगा वहाँ पे, तो minus 3 है, तो 3a plus b minus c equals to 0. If we for the equations to be consistent, to have a solution, the ABC must have this relation. Yeah, okay.